Hello everyone. Um, Today I am talking about a Cipher 10 image classification using PCA and multiple classification. What we will cover: data processing and PCA, training decision tree, SVM and naive Bayes, evaluating and comparison model performance, and last one is visualizing the results. So let's talk about the part one is classifying with the decision tree, SVM, naive Bayes, importing the necessary library in order to proceed the machine learning algorithm. The first one is important necessary libraries, sklearn libraries from the machine learning. So the first step is load the Cipher 10 dataset, and here the display of the first few rows. Then after we go for the pre-processing data like Platon normalize and split into training and testing set, and we have to flatten image convert into 32 by 32 into 3 into 1D vector of 3022 features. Then after we go for the normalized data into 0 to 255. That the 0 represent the lighter and 255 represent the darkest image. Then after we have to convert the label data into 1D. Then after we go for the split data into X and Y target. So here the part one is train a decision tree classifier. So we have to implement the decision tree classifier using the max depth is 10, and the train model we have to fit, and then after we go for the prediction, and here the print the classification report, and the model performance is accuracy is 0.10, precision is 11, recall is 10, and f1 is 0.02%. And then after we use a PCA for the feature selection, apply the PCA, and after apply PCA and fixing the memory issue, instead of 95 variants we choose a 150 component, and print info is original features, and second is the PCA component. Original feature is represented 3072, and PCA component represent the 150 features. Then after we go for the train decision tree on PCA redux data. So if we have to implement the fit and predict, then after we go for the model performance. So here the model performance comparison is accuracy 0.10, precision is 0.11, 0.10, f1 is 0.02%. Then after you go for the PCA deduct model, accuracy is 0.15, nice, precision is 0.16, great, recall is 0.15, and f1 is also increased to 0.15. Thereafter we go for the visualization of original model and PCA model. So here the visualization of original versus PCA model. So here the blue represent the original model and green represent the PCA model. Then after we go for the part 2 is train a SVM support vector machine classifier, and we have to implement the fit, and then after we go for the predict test into PCA. Then after we go for the report classification. Then after we go for the model performance, and model performance is 0.10, and then after we use for the PCA for the feature selection. Then after we go for the print info original features and the PCA components same as the previous, and then after we go for the train SVM on the PCA reduce data, and train the module PCA classifiers, and make prediction. Then after we go for the model performance, we let's see the original model and the PCA reduced model. So here the accuracy is 0.10, and the precision is 0.10, recall is 0.10, f1 is 0.02. So then after we go for the PCA reduced model, accuracy is 0.16, that increase precision is 0.17, and the recall and f1 is 0.16, is nice. Then after we go for the visualization of original module and PCA module. So here the blue represent the original module, and the green represent the PCA module, and the x-axis show the metrics and y-axis show the scores. So then after we go for the part 3 is naive Bayes classifier. Then after we have to implement the fit and predict dataset. Then after we go for the classification report and the model performance. So here the model performance of So we have to we go for the use of PCA feature selection. After apply the PCA, we have to fit underscore transform. Then after PCA dot transform, and we have to same as previous. We have to print a PCA info original features and PCA component. Then after we go for the naive based tree PCA reduce data. Then after we go for the fit and predict same as process. Then after we go for the model performance, we have to evaluate the model on the basis of our data set. So here the original module, all the features, accuracy is 0.10, precision is 0.11, recall is 0.10, f1 is 0.02, and the PCA reduced data is 0.10, precision is 0.13. So here is recall is 0.10 and f1 is 0.03. So there are minor changes, but it's fine. After we go for the visualization of original module and PCA module. So here the visualization of the module is the blue represent the original and the orange represent the PCA reduced data. So here the accuracy, precision, recall and f1, and the score is 0.2, something like that. Thereafter we go for the model comparison of decision tree, SVM and naive Bayes. So here the model comparison of decision tree PCA is accuracy 0.16, precision 0.17, recall is 0.16, f1 is 0.16. After we go for the SVM PCA performance, accuracy 0.16, precision is 17. So here the SVM and decision tree is a similar, and the naive Bayes is a very lower. So thereafter in my project to I consider we have to go for the decision tree because it's very easy to implement in our data set, and it's more easy to do it. Thereafter we go for the visualization of the comparison. So here the comparison, the blue represent the decision tree PCA, green represent the SVM PCA, and last one represent the naive Bayes PCA. So here the my code. Thank you so much, guys.